Hey, what's up, folks? How we doing? Coming to you with a little breakdown on the last Friday's pop quiz on factoring and dividing. And I'll come to you with a quick little breakdown on how it goes, as well as some words of wisdom here. So when we break this down, I just want to think about a couple things here. The first one is I saw a lot of people working really hard, really hammering away at the division, and they spent a lot of time making sure the division was correct. And I think the thing is that this cost people a lot of time in the long run, because in the effort to make sure your division was on point, you spent a lot of time, and I think people got stressed out as a lot of people originally or eventually did not notice that there was a zero coefficient. So a lot of people got confused, one, because they were like, what's going on, something's happening, and because if they did the synthetic, they did not put the zero in there, okay? And the zero not being in there, as I said a couple times at least, will throw everything off. I'm going to show you two different breakdowns on this, one using the box, one using synthetic division. So if you're going to synthetic, you drop your 3 because 3 makes this 0. Okay, you do 1, 0, -2, 6, 5. 1, 0, -2, 6, 5. Make sure you have all of your coefficients in there. Okay. Now, though some people did, I don't wanna shame everyone, because some people did do a very good job, and they noticed that synthetic, boom, 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 gets us the answers. Very good if you noticed that. Now I drop the 1. 1 times 3 is 3. Add the 0 and the 3. Multiply, getting 9. Adding the -2 and the 9, getting 7. 7 times 3, giving me 21. 21 plus 6, giving me 27. 27 times 3, that you had a calculator for, giving me 81. Adding up 5 and 81, getting 86. So our answer is boom, boom, boom. X cubed plus 3x squared plus 7x plus 27 plus 86 over x minus 3. Most of the things I saw here, those of you who did the synthetic, 1, missing the 0, and 2, there was a little minor math error adding up the 5 and the 81. I did try to give you guys calcs, 1, and out of respect to the fact that it was a very on-the-spot thing. I did feel that doing some of the arithmetic would have kind of limited the already limited time. So I did want to not, break down barriers. I was more concerned, could you do it? The big idea is the division, then could you do the actual like addition and multiplication? That wasn't so much of a concern for me, but it was kind of like a blown opportunity if you kind of didn't use your calculator where you could have used your calc. Now, real quick on the back, I'm going to show you the other way to do it. So again, our problem was x to the 4th minus 2x squared plus 6x plus 5 divided by x minus 3. So here's the box. I'm going to set up my box, put my answer on the bottom. Okay, put my x, my minus 3, do that out. And I like to make my box an indeterminate length because I don't really know what the final answer is going to be, and that's all right. So I drop my x to the 4th here. Okay, for this to be x to the 4th, I need an x cubed, because x cubed times x equals x to the 4th. Now I do my x cubed minus 3, that's -3x cubed. And my final answer, I have no x cubed, and this was the throw off for some people, so this has to be a 3x cubed, so they cancel. Okay, then I put a 3x squared, because to get this to be 3x squared, I have to have 3x squared times x, and then 3x squared times -3, that's -9x squareds. I need 2x squareds in my answer, so this has to be, or -2 rather, so this has to be positive 7x squared, because -9 plus 7 is -2, so it needs to be 7x, right, because 7x times x is 7x squared. 7 times -3, that's -21x. Now I need to do a total of 6x in my answer, so this needs to be 27x, because 21 plus 27 is 6. That's where that strategy can get tough. So this needs to be 27. And then 27 times negative 3, that's negative 81. So I get a negative 81. I need to get to a positive 5. That means this needs to be 86 because negative 81 plus 86 is positive 5. And remember, this is one of the downsides to the box. If you do get a remainder, it's sometimes difficult to, go through that process of what is the remainder. So this is our final answer. Again, you'll notice it's the same as on the front. All right, one last method, long division. For those of you who did long division, okay, remembering with your long division, you want to write in your zero coefficients. So x to the fourth plus 0x cubed minus 2x squared plus 6x plus 5. Okay, so I do leading term. What times x is x to the fourth? That's x cubed, and that's why I drop in the 0. Multiply by both, that's x to the fourth minus 3x cubed. So I subtract, these cancel. 0 minus negative 3 is positive 3x cubed, and I bring down the rest. Now again, what times x is 3x cubed? That's going to be 3x squared. And again, noticing how when I multiply by this, I get what needs to cancel. 3x squared times negative 3, that's negative 9x squared. Negative 2 minus negative 9 becomes 7x squared. Again, bring down the rest. Okay, what times x is 7x squared? That's 7x. Okay, 7 times x is 7x squared, or rather 7x times x. 7x times negative 3, negative 21x. Cancels. 6 minus negative 21, that's 27x. Last piece, drop in the 27, because 27 times x is 27x. Bring it down, you have 27x minus 81. 5 minus negative 81 gives me 86, my remainder. So I come up, write that in. Okay, so I've shown you 3 different ways to do it, and I challenge you to go and take a look at the 3 ways I did it. Box, traditional, synthetic. And ask yourself, is this as you want a quiz or a test? And I say divide. I said divide. I don't care how you do it the best way. What is going to work for you, given the setup and the complexities around that, given the time constraint? Because the unfortunate thing with tests is that sometimes doing well on tests is not so much as do you know how to do it? And that's important, don't get me wrong. But sometimes it's about do you know the most efficient way to do it? And I'm trying to get you guys ready for these tests that you're not going to have a lot of time on. When we think about the SATs, we need to get those answers fast. When we think about things like college, because I care about you guys, I want you to be ready for college, you got to come under that heat where you got to think about the best way to do things, okay? All right, so I'm now going to come ahead and do the second one. The second one, I would say maybe a max of 2 people attempted the synthetic. Those who did the synthetic did not do it correctly, because in the synthetic, you need to make this equal to 0. Okay? So what that means is you do not want to do negative 1. Negative 1 does not make this 0. Negative 1/3 is what you need to have put in there. I'm not going to, and so what I said in class is I'm like, listen guys, we probably do not want to synthetic this out. You could do it, and I'll show you how to do it. However, syntheticing it out is not an ideal way to do it, especially because, think about it, this has 1, 2, 3, 5 coefficients to knock out. This has 4. So if you do another method, those coefficients are going to knock out that much faster. So again, the idea is you want to make this 0. And negative 1/3, if I plug it in, look, negative 1/3 times 3, negative 1 plus 1 is 0. Okay, so remember, synthetic works when we're talking about a linear. However, when we have a coefficient in front of the x, that is going to affect the answer. Again, you want to cancel this second term out. That's what goes there. So I copy my coefficients: 6, 14, negative 11, 3. I will also say, one thing that threw people off, you noticed at the beginning, I did you a favor here. Look, this was going to come out to be ugly. I did you a favor. I changed these coefficients so that everything will come out clean. A lot of people did not cross out this and ended up doing the math with this, and that was kind of unfortunate because I really think you guys could have done it with the fixed one very easily. All right, so here I go. I bring down the 6. I get 6. Okay, I multiply 6 by a negative 1/3. Okay, and that gives me negative 2. Okay, I do negative 14 minus 2, giving me 12. Now, on the original one, you would not have the numbers coming out this nice, unfortunately. I do 12 times the negative 1/3, I get negative 4. I do negative 11 minus 4, giving me negative 15. Okay? Now, what comes next? Negative 11 minus 4, giving me 15. Negative 15. I do negative 15 times negative 1/3 gives me a total of 5. Add the 5, I get 8. Okay, and now I need to see what went wrong on my end, because I even got a different answer than this. This is kind of weird, and this is why doing this synthetic can be a tough cookie sometimes. Here's the deal. What's confusing for me is that actually the answer you get is not this answer at all. And that's one thing, the reason why the synthetic can be tough. Okay, because you got to take a look at this. And the issue is that the negative 1/3 actually throws everything off. Because the answer you actually get is also different. The answer you should get is not this answer at all. You actually end up getting 1/3 of each of these. So what you actually should end up getting is 2x squared plus 4x minus 5. Okay, and the reason it has to do with the fact that you have that ugly coefficient there, and that really messes everything up, though the remainder is correct. And this is the reason that I don't recommend doing the synthetic, because there's a couple of tricks here. The one trick being that you have to have that negative coming out. That's kind of weird. And the other trick being that your answer could be deceiving to you at first. So here's what I'm going to say. Let's avoid doing synthetic when we have a number in front of A, because that's going to come out weird. And so I think we could do a better way in that case. Okay, so here's what I'm going to do. I'm going to show you it using another one of the methods. So our problem was 6x cubed plus 14x squared minus 11x plus 3. Okay, divided by 3x plus 1. I'm going to recommend we try the box on this one. So we have 3x and we have 1. Now, and this is a disclaimer. Some people did try the long division to complete success, and I'm not knocking that method either. All right, so here I go. I need to get 6x cubed in my big guy up here. So this needs to be a 2x squared, because 2x squared times 3x giving me 6x cubed. 2x squared comes down here. I need 14x squareds in my answer. So this needs to be a 12x squared. Drop it. Needs to be a 4x, because 4 times 3 is 12. X times x is x squared. And a 4x down here, because 4x times 1 is 4x. In my answer, I have negative 11x's, so I need a negative 15x. So this has to be negative 5, because 3x times negative 5 is negative 15x. And then this becomes a negative 5. I have a negative 5. I need to get to 3. Negative 5 plus 8 is 3. Give me a remainder of 8. Last way to do it. Let's go ahead and do my traditional division. 3x plus 1 into 6x cubed plus 14x squared minus 11x plus 3. And again, the reason I'm going for the box or the long division is because in my mind, there's less tricks. With the synthetic, we got a number in front of the x. All this new stuff has to happen. That's one more thing to remember in my mind. There's nothing new. There's no tricks when we switch it. Okay, so now watch. Leading term over leading term. 6 divided by 3, 2. X cubed over x, x squared. So 3 times 2 is 6. X squared times x is x cubed. So I do it out. 6x cubed. These are the same. I know I got that right. 2 times 1, 2x squared. Okay, good job. Now these bring down. 14 minus 2, that's 12. I get this right here. Now what I do is I do 12x squared over 3x, giving me 4x. Notice 4 times 3 is 12. X times x is x squared. So I get a total of 12x squared plus 4x. Sorry, I was kind of stuck there for a second. Negative 11, so again, we do the subtraction. Negative 11 plus 4 is, in this case, it's minus 4. So it's 15, negative 15x, because remember, it's a negative minus a positive. And that's another reason why this can be tough for people. And then lastly, negative 15, this has to be a minus 5, because negative 5 times 3x is negative 15x. Bring in that. And this was tough for people too. 3 minus negative 5 gives me positive 8. So again, we had 3 ways of doing this. Synthetic, okay, box, long division. Now, again, let's just do a quick recap. With a synthetic, 1, we had to pull that 1/3 out and go third, third, third. But in the end, actually, we had to even do more work here. I don't know, guys. I don't know how I feel about that one. I just feel like there's too many tricks. There's too much stuff working at once. I would be really hesitant. I think in my mind, and you can disagree, and I totally respect that, synthetic seems to work good here because just boom, 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 good. I want you guys, you guys aren't dogs. I don't teach you tricks. I want to have ways that are going to work always. Again, if you want to learn those manipulations, I'm not going to hate on you as long as you can get the correct answer. But this just seems to me too deceiving to be a good idea. Again, my opinion. Here we go to the box. The box, as long as you can reason through it, and the sad thing was many people forgot to switch this, because I know if you'd switched it, you would have been able to do that. I know it. Here, there's no tricks, no zeros, nothing to cancel out. We just work through it one piece at a time. And finally, the long division, equally good. Only thing is, you just have to remember when to do the subtracting and when to do the adding. And in some cases, that just threw off people's remainder. All right, so I know this is a long explanation. If you need time, go back and take a look through. Otherwise, I'll move on to the next part. Okay, now it's time to factor completely. So in this case, a lot of people saw right away, 1 worked. So what I'm going to do is, I'm going to factor out my x minus 1. And again, I'm dividing, so this is a good time to do the synthetic. So my coefficients, as long as you remember, 1, 0, 5, negative 6. Again, if you miss the 0, it's kind of game over there. So drop the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 5 plus 6 is 1. 6 times 1 is 6. Negative 6 plus 6 is 0. If you did not get a 0 for your remainder, that's telling you this number can't be, because if it's a factor, you're not going to have a remainder. So come up here, x squared plus x plus 6. I come back through. Can I factor this? This? Nope. Factored. This. All right. Well, there's no numbers I can tell that multiply to 6 and add to 1. Now, some people said negative 3 and negative 2. Valiant. See why? Because it adds to 1. But if this is positive, your numbers both have to be positive. So you're actually done here. You can't factor this anymore due to the fact that the x squared plus x plus 6 doesn't break down. And actually, if you do the discriminant, b squared minus 4ac, right? You'd have 1 minus 24. That's going to be a negative discriminant, meaning there cannot be factors, because if you have a negative discriminant, remember, that means no real solutions, okay? And if you have no real solutions, there's no way you could factor. On the second one, I gave you guys a hint, which is that x plus 4 is a factor. So that means that we immediately have to go into factoring with the x plus 4 in mind. So I need a negative 4, because if x plus 4 is a factor, then I must be able to make this equal to 0. So that's the negative 4. Then this one, straightforward, no zero coefficients. Negative 1, negative 7, negative 20, 96. Okay? Some of you even made a synthetic division table. Good, I like that, from the rational roots. Bring down the 1, we get 1. 1 times negative 4, negative 4. These added up gives me negative 11. Negative 11 times 4, negative 4, that's 44. Add those, you get a positive 24. 24 times negative 4, that's 96. Bring them in, you get 0, which we expect because it's a factor. And now I do my final thing, x plus 4, x squared minus 11x plus 24. Now, again, can I factor this? No, it's linear, no GCFs, done. Here, can I factor it? Well, are there two numbers that multiply to positive 24 and add to negative 11? Well, let's think about this. I got a positive and a negative. So I need two negative numbers, because a negative times a negative is a positive, and a negative plus a negative is a negative. Which means that, are there any two negatives that add to negative 11 and multiply to 24? Yes. It could be negative 3 and negative 8. So sometimes the quadratics can be factored, sometimes they cannot. Okay, so go ahead, if you need to take a look at problems 3 and 4, do that, and then in a second I will move on. All right, now we're on to the solve for x, okay? So 100% of people did an outstanding job making it equal to 0. X cubed plus, in this case, move over the 6, 6x squared plus 3x minus 10. Outstanding to see that. Now, hint, x minus 2 is a solution. X equals minus 2 rather is a solution, meaning that immediately we could take a factor here. X plus 2 has to be a factor, because if this is equal to 0, then that means that if negative 2 is a solution, when I plug in negative 2, this cancels out. So now I set up my synthetic. Outstanding to those of you who set it up, and I gave you a little bit of extra room here to set that up. Box it. So again, we're in a situation where bussing it or syntheticing it is easy because I have a 1 in front of there. And I'm telling you, when I give you a problem of factoring, there's always going to be a 1 in front of the x. So that's where we want to use that synthetic to cut the time down. All right. So let's drop in our coefficients. We got 1, 6, 3, negative 10. Okay. So here I go. Bring down the 1. I get a 1. 1 times negative 2. Negative 2, 6 minus 2 is 4. 4 times negative 2, that's negative 8. 3 plus negative 8, that's going to be negative 5. Negative 5 times negative 2 is 10. 10 plus 10 is 0, as expected. So I have x squared plus 4x minus 5. Okay, that's my factoring. Let's see, can I break this down more? Well, are there two numbers that multiply to negative 5 and add to 4? Yes. So let's factor it. X plus, let's see. Well, it's got to be a plus and a minus. 5x minus 1. And if this is equal to 0, let's see. Well, negative 2, which we knew. And unfortunately, I cannot give you credit if you just wrote down negative 2. No offense, I already gave you that. X equals negative 5, and x equals positive 1. Because negative 5 cancels this, 1 cancels this, negative 2 cancels that. And again, when you see 3 as your biggest power, you should expect up to 3 zeros as your final solution. All right, now I'm going to come down to my last problem here, and I need to simplify. Pretty good job. The one mistake that I saw was distributing the power. You cannot do that. It's really, I really kind of, a little bit, I don't know how to say this, maybe anxious to see people distributing that power. You cannot do that. You cannot do it, okay? That was really tough because, like, we have to remember you couldn't do that with a square. You definitely can't do that with a cube. Okay, I love to see people writing it out like this, and you're just going to take this one piece at a time. So I'm going to come and I'm going to do this part first. So I do the x plus 1 times the x plus 1. I get x squared plus 2x plus 1 times x plus 1. If I factor that out, I get x cubed plus 2x squared plus x squared plus 2x plus 1. So I get x cubed plus 3x squared plus 3x plus 1. This actually comes from Pascal's triangle. I don't know if you guys have seen Pascal's triangle. Pascal's triangle actually tells you the coefficients of multiplying a certain binomial like x plus 1 over and over in like the squared format. So this would be x plus 1 to the 0, x plus 1 to the 1, x plus 1 to the 2, x plus 1 to the 3. And you have 1, 4, 6, 4, 1. If I did x plus 4 to the 4th, I would get a similar thing like that. All right, so I'll hold this off to the side. Now I'll go ahead and I'll FOIL this one out. So I get x cubed minus 6x. Well, really what I should do is I did the minus 6x. I guess the order doesn't matter. Minus 3x squared plus 2x squared. Let me just make sure I got that. X cubed plus 2x squared minus 3x minus 6. Minus 3x squared minus 6. Okay. Let's pull that in. So I get x cubed. These become a negative x squared minus 6x. And now what I want to do is I want to minus x cubed plus 3x squared plus 3x plus 1. Now let's take a look. X cubed minus x cubed. Gone. Negative x squared minus 3x squared. Because I'm minusing this. Negative 6x minus 3x. 0 minus 1. Okay, so not an easy one. A lot of people were outstanding to the extent that they got the second piece, but there's a lot of moving parts. Here's the other mistake I saw people making. This is a minus. I saw a lot of people multiplying, and that kind of made it harder on yourself than need be. All right, so again, I hope you found this video informational. I know some of it might be long-winded. Keeping in mind, you didn't need to see all three versions of multiplication, or rather division, up at the top. But again, it's really important that you understand, where you're getting it and where we need to continue to work, because we will have that unit test soon. So again, take a look at this, reach out to me with questions, come for the extra help, because I can't help you unless you help me help you. But remember, most of all, you can do it. All right, keep believing in yourself. Don't let this be discouraging to you. And as long as you want to be successful, I can help you be successful. All right, so again, have a wonderful day. Keep at it, and don't forget to love math.